we are going to have another instance where we have a missing term, but if you look at what we're dividing into, there's no issues there. It goes by highest degree is 4, then 3, then 2, then 1, then a constant term, a degree of 0 there. That one's fine. The issue is on the outside this time. It doesn't matter if the inside or the outside is missing a term, you have to fill the gap. So we're going to set this problem up correctly and then work it through. So 3x to the 4 minus 6x to the third plus 29x squared plus x minus 1. And then on the front, we're going to get a 3x squared and a minus 1. That gap, the little place that I've made space for, needs to be a linear term. And since it's not there, the only way we can add something without really adding it is adding a 0. So add a 0x to the 1. Linear term right there. We have to have from highest to degree 0 every time, inside and outside the division. Once it's set up correctly, it's just following the algorithm. So the biggest mistake people make is they just miss that part. The rest of their work looks great, and it's just like, oh, we're just missing a term from the beginning. So we take our 3x to the fourth and ask what do we multiply 3x squared by up top? To get 3x to the fourth, well, the 3 is already there, so we just need another 2 x's. An x to the second, an increase of degree of 2. So now we distribute that x to the second, and the result down below is going to be 3x to the 4. And then times the 0 is just a 0. So we say, you can just say plus 0. You don't have to put the x at all because it's just a 0. And then minus 1 times x to the second will be negative x to the second. Now, if you want, you can put that 0 and then you could count degrees, and it's actually 1 and 2 to be a degree of 3. And again, that part doesn't matter. What matters is that this is a 0. Anyway, now we go ahead and distribute a negative here into this trinomial, although it's technically a binomial because there's just 0. Anyway, side note, this is negative 3x to the fourth, and then 0 still. Doesn't matter, the sign changes there. And then distribute the negative here, and we get a plus to override that negative sign. And as always, the first term should cancel, which it does. This second term, don't ignore it because that 0 is there. You got to bring down this negative 6x to the third. And the whole reason that 0 was there was to put this x to the second underneath its like term. So this will actually get you 30x to the second. And then you bring down your x, your next term. So we need a trinomial match to match the trinomial, including the 0 out in front. So then we look up top and decide what do we multiply 3x squared by to get a negative 6x to the third. And that's going to be a negative 2, and we need one more degree, so negative 2x. And then we take that negative 2x and distribute it to all three of these out in front, which is going to get me a negative 6x to the third, and then plus a 0, and then plus, because negative 2 times negative 1 is going to be positive 2x. And as the algorithm calls for, we need to distribute a negative here to subtract that quantity, which will get me a positive 6x to the third, 0, still 0, and then negative 2x. So the first term should cancel, which it does. Second term, we bring down our 30x squared, and then we have a negative 2 positive x, which gives us a negative x, and bring down your negative 1. And then we look one more time and ask ourselves, what do we multiply 3x squared by to get 30, and that's 10. So 10 distributes over here. 10 times 3 gives me the 30. So I get 30x squared, 0, and then plus 0, and then minus 10. So then I go ahead and make sure that I get a negative sign down here to be distributed to subtract that quantity. The 30 will cancel to be a negative 30. 0 is still 0, and then it's going to be a positive 10. So as I add, I'm going to get negative x and positive 9. That's my remainder, and that's okay. I have a remainder. It just goes up top next to my quotient so far, and you put it over top of a fraction bar. So it's going to be negative x plus 9, and it needs to be divided still by 3x squared minus 1 because it didn't go in evenly. So this in the box is the final result from dividing with long division this quadratic into this quartic.